if you do want to participate, jump on over into our other channels. It looks like everything's going all good. Everyone's letting me know they can hear me, so that is good. Well, everyone, we have a great topic, and I'm pretty excited about this. I'll explain why in a minute, but I have already introduced our guest, C.J May, and we're going to be talking about securing our GitHub Actions and workflows, keeping them secure. Which isn't a topic that we've covered on the webinar before, but we do have a blog post about this. And we're going to be covering some really, really interesting stuff with CJ on this. So a little bit about how today is going to go. If it's your first time at one of the Git Guardian webinars, welcome to the show. So we'll do a little bit of an intro where we'll explain some of the things that will happen. We're going to talk about what are GitHub Actions very quickly. Then we're going to dive straight into some of the best practices. And then, this is why I'm so excited, we have a live demo of some injection with GitHub Actions. So CJ, not me, I'm not clever enough, but CJ is going to show us how we can use some of these best practices, or the reverse of them, how we can actually use some techniques to turn GitHub Actions malicious, to actually do bad things. So we're going to show that live. So that's going to be really cool, really interesting. And then we have our wrap up at the end and some Q&As. So you guys will all have an opportunity to participate, to say hi. So if you're in the Crowdcast platform, you'll notice down the bottom, you obviously probably can see the chat function, but there's also a poll button. We do have we only have one poll today, but still there. And there's also a button that says ask a question. So if you want to ask a question to CJ or myself, but probably CJ, then you can do that in the ask a question tab. And you can actually upvote everyone's question. So if there's a particularly good question that you definitely want answered, then make sure you upvote those questions. That way we'll definitely be able to see it. We had over 500 people register for this webinar. So there may be quite a lot of activity in here, or at least I hope so. So prizes. As always, we have some prizes. Now, we've had some logistical challenges with our swag bags. So we do have swag bags available, but we also have Amazon gift cards. So we will be giving away some prizes that, depending on where you live, will depend on what prize you get, or if you particularly want one, I'll accommodate that. So how do you win prizes? Well, lots of ways you can win prizes: by participating, by asking questions, by saying hi in the chat a lot, or commenting on things. All of that gets up. I have a magic button at the bottom where I will generate a list of who are our most active people on the webinar, at which point you will win some prizes. And I also have some other ways to win prizes along the way. So first of all, while we're still waiting for a few people to join, let us know where you're tuning in from. So I'll start. I'm actually not in Paris today. I'm in Prague, in Czech Republic. I'm speaking at the Qubit conference here, which is pretty cool. But that's why I'm in my hotel room today. So not a very inspired backdrop, but it does the trick. CJ, whereabouts are you tuning in from?
Yeah, I'm from Pella, Iowa, which is in the United States. It's a smallish town of about 10,000 people.
Ah, very cool. All right, so we have some here. Toronto, Russia, Miami, Amsterdam, Goedenavond. From Amsterdam, Brazil, France, Malaysia, Italy, Armenia, Lagos, Morocco. Wow, I love seeing all these countries come in. New York City. I'm going to be in New York City next week for Data Connectors Conference. So if anyone's going to the Data Connectors Conference in New York, you'll see me there. Or if you're going to the B-Sides or RSA Conference in San Francisco, I will also be there. I think it's in 2 weeks. I'm not sure. But if you are in RSA or San Francisco and you want to meet up, I'm doing some talks there. We have a booth. But best way, you can just find me on Twitter or LinkedIn, send me a message and come say hi. Lots of cool places still coming in. Ghana, Kenya, Ukraine, Bulgaria, Mexico. Wow, we got a couple of people from Ukraine. Oh, this is great. All right. Let's get stuck into it. So we have our first poll of the day. So, where are you currently at with GitHub Actions? Are you new to it? Do you have any idea what it is? What it is? Are you starting to use some basic actions? Do you use GitHub Actions as part of your organizations? Are you a GitHub Actions power user? Going through that, and I don't have the option here, but GitHub Actions is obviously only on GitHubs. The equivalent on GitLab is your pipeline. So if you are a GitLab user, there is a cheeky button for you to but we're going to be talking about GitHub Actions today. Now, one last thing before we get in, I have a quick story to tell you. We're currently looking for some stories about leaked credentials. Now, it's a little bit, it's not entirely what we're going to be talking about today, but GitGuardian, as you probably know, is a company that detects credentials that are leaked in different places. And there's some pretty hilarious stories out there of how these are leaked. So you can do this anonymously, but we are looking for the best stories of how you've leaked a credential or when one has been exposed. And if you share your story with it, you can share it with me on Twitter, on LinkedIn. You can email me. My email's at the bottom of the screen there. Or you can send it to GitGuardian. If you do this, then there might be some prizes coming your way. So before we get stuck in, I have one funny story that I would like to share with everyone. It takes exactly 1 minute and 30 seconds. So I'm going to quickly introduce this story in here, and then we're going to get stuck into some GitHub Actions. So remember, if you want to win some prizes, make sure you share your stories with us about how you have accidentally leaked a credential in the past. I'll share one with you right now.
So, I'm the happy father of a little girl of 3 years old. So 3 years ago, my daughter, my wife was pregnant, and I was working from home close to her. She was due really soon. We didn't really know when, but I was working, and I was working for Algolia on my computer at that time, and I needed to upload a bunch of images to S3, and so I had been given a credential key to upload my stuff on S3 for the test. And while I was writing my code, I realized like it was time to go to the hospital. My wife was about to give birth, so we went there, spent 1 week completely disconnected from work, came back home 1 week later with the laptop still open. I just saved my work, commit, push, and moved on to other things. What happened is actually I pushed the key because it was written, I had just copy pasted it in a file somewhere. I pushed it to GitHub, and it was caught by GitGuardian pretty quickly. That sent a notification to the security team at Algolia, and turned out that this key was actually had more rights than necessary. It was not just to upload stuff to S3. And so while I was quietly on my paternity leave, taking care of my wife and daughter, it was like the chaos at Algolia because we just leaked a very important key. And thanks to GitGuardian, they managed to know that pretty quickly and change all the keys everywhere. And I knew that only when I came back from my paternity leave. Like I saw all the Slack messages like, crisis, there's a big problem. I was like, okay, thank you, GitGuardian. You saved my ass.
That's my favorite story. Pushing a key, your wife goes into labor, and then when you come back from your paternity leave, you found out that you've pushed some production credentials. But anyway, so share those stories with us if you have them. But we are going to get stuck into the subject at hand, which is GitHub Actions. So let's start. I just had a look in the poll. So most people are fairly new to GitHub Actions, but they know what it is, and they know and they've been working with some basic actions. We have a couple of power users. We have a couple of GitLab for Life people, and and we have a couple of people that are just learning it out. So most of you are kind of starting in that. So, CJ, maybe you can explain a little bit. What are GitHub Actions? Why do we use them?
Yeah, so GitHub Actions are an offering that GitHub has that basically enable you to run automations on your code. So let's say that you push an update to your code. It can do things like kicking off automated tests or doing some security scanning of your code, kind of like GitGuardian does, where you might be looking for secrets that you might have accidentally committed to your code. So yeah, GitHub Actions are just kind of a way to automate different checks and stuff like that.
Yeah. Okay. Cool. So a way that we can kind of integrate it with that CI/CD environments, that automated check and automated scanning. So an important part of modern development, if we have some maturity, then we're going to be using some kind of actions or pipeline. So it's really important that we understand how to secure these. So we've got a lot of content, so I'm not going to muck around. We're not going to muck around here today. We're going to list some of the best practices of how we can keep our actions secure. We're going to go through them one by one. And then CJ is going to demonstrate what happens if you don't follow these. So let's start with the first one that we have. Set minimum scope for credentials. What credentials are we talking about in this case with GitHub Actions? And how does this kind of keep us safe, and what are the consequences if we don't do this?
Yeah, so when we talk about credentials in GitHub Actions, usually we're talking about API keys or a GitHub token. So API keys, typically you can configure the permissions for that on the platform that the API key is for. With GitHub tokens, it's a little bit different. So by default, the GitHub token that runs in your actions has read and write access to whatever repository it's running in the context of. And so, but there is a way for you to change that in your repository settings. And so you can either change that to read write to read only. And if you want to get more granular than that, you can create a personal access token. That's part of your account settings. You can create a personal access token that really gets nitty gritty with the permissions that that token has. And then you can add that as a secret in your repository and use that token.
Right. Okay. So so if we don't have minimum scopes for these credentials, and they do get it, and they do potentially get exposed, then basically someone that is able to exploit them is able to do a whole bunch more damage, move laterally into different areas.
Mm-hmm. Yep, exactly.
Okay. So let's get a little bit more kind of in detailed into some of the GitHub Actions specificities. So we have here best practice number 2: use specific action version tags. So firstly, what is an action version tag, and what are the advantages of using a specific tag?
Yeah, so when you use a GitHub action in your workflows, you're basically running some code that somebody else has out there. And this is in a public repository, so you could go search for that on GitHub and see exactly what it's doing under the hood. But basically, these tags that you see on the line where it says uses actions checkout at v3, at v3 is referring to a specific version of that action. And basically, there is a little bit of inherent danger there because you're running somebody else's code. And unless you are, constantly vetting updates to that tag, because, it can be repushed or re-tagged on a newer version, unless you're constantly vetting those updates, you don't necessarily know exactly what code is running in your workflow. And so kind of a way to protect yourself against that is to maybe vet a specific version of that code. And then you can, instead of referencing the tag, you can actually reference the commit hash. So it's actually a very specific version that, is harder, even impossible to spoof, because you can't just, re-tag v3. If you look at the second picture there, we've got, we're logging into the Docker container registry, and we're using a very specific version of that action, so that, if, let's say that for some reason that action, that repo got taken over, and some malicious actor was modifying what that action was doing and maybe stealing your Docker credentials, by referencing that specific commit hash, we're kind of protecting ourselves from those updates that might happen down the line.
Right. Yeah. And an interesting one on this one, it was the Code Cov breach of last year, because Code Cov was being used in GitHub Actions. The action itself was turned malicious, so attackers were able to edit Code Cov's code. And if you ran that wild code, that malicious version, then the attackers actually got access to your GitHub repository. It's a, but that could have been avoided, right? If we had used a specific version of CodeCov that we knew was clean, that we didn't, then we could have prevented from having that malicious threat.
Yep, that's a great example.
All right, number 3, my favorite one. Don't use plain text secrets. So we don't need to talk about much. If you've seen any webinars ever, this comes up at least once. So don't use. So why? But let's humor me here, CJ. Why shouldn't we use plain text secrets? And how do we not use plain text secrets?
So yeah, I mean, obviously, if you have plain text secrets in your code and it's an open source repository, anybody can see that. So, as soon as you commit it, there's probably, bots and researchers and all sorts of people that are scanning GitHub constantly to try to find stuff like this. And so it doesn't take long for something to get discovered if you accidentally commit like an API key or something like that. So, whether it's in your code or it's in your actual GitHub Actions workflow file, there's just no place for plain text secrets in any sort of file that you're hosting on GitHub.
Got it. Okay. So I can't spell this out for don't use plain text secrets. All right. Now let's get into one. Now this one's actually this one has a little bit more complexity to it. And I believe this is kind of around one of the demos that you might be doing later on, CJ, if I'm not mistaken. Okay. Yeah. So here we're saying don't reference values that you don't control. Okay. So what are the values that we don't control, and how do we not reference them?
Mm-hmm. So when you are setting up a GitHub Actions workflow, there's certain built-in variables that GitHub allows you to use. In the example that we have here on the screen, this one is printing out the pull request title, and then it's running commit lint on that. And so what's actually happening is it's grabbing the pull request title, but if you think about that, that's not something that you control as the repository owner. That's something that whoever is creating that pull request, they can make that title whatever they want. So let's say that I opened a pull request to this repository and I named my pull request that line there where it's, downloading some malware and then executing it. Then what actually happens is when that gets evaluated during the GitHub Actions workflow execution, that'll actually inject that variable onto the command line, and it'll run as shown in that second image there at the bottom.
Right. Okay. So by changing the pull request title, you can actually execute commands. You can you could run a remote script somewhere.
Yeah, and it's not just the pull request title. There's other variables like issue title. There's a lot of built-in variables that GitHub offers you to use. But if you're using built-in GitHub variables, just make sure that you understand whether or not you control that input that you're using that's in that variable.
Okay. So we have some more kind of examples of this. Using an action instead of an inline script. So what's the difference between here and how does that kind of solve some of this problem?
Mm-hmm. So before on the last page, what we were doing was we were actually using that variable directly on the command line because we had, our run tag in our YAML file, and then we had that unsanitized input directly on the command line. So basically what these two fixes are doing is it's kind of redirecting that input or kind of adding a little bit of a second layer to kind of sanitize that or de-weaponize it, I guess is probably a better term for it. And so, yeah, that first one where we're not actually using a command line, we're using an action instead. So here we're using some fake action where we're checking the title and then we're just inputting that variable as a parameter to that action. And then another way that you can de-weaponize unsanitized input is if you have to use it on the command line, what you can actually do is you can create an environment variable in your action for that step, like we see below on that second image. And basically you create the environment variable, and then you actually just reference the environment variable instead of the GitHub variable itself.
Right. Okay. Okay. So we're basically taking things that we have no control over, and then, you know, we're not using them where possible, and then we're adding in added layers of protection that prevent someone from being able to overtake that. Okay, I'm really excited to see the demo that you have of this, CJ, because yes, we're going to talk about all these things, but we are also going to, well, CJ, I say we because it makes me feel better, but CJ is going to demonstrate how these actually work in practice in a live demo. Because what goes wrong when you do live demos? So let's move on. Number 5. Okay, only run workflows on trusted code. So what are we talking about here when we're talking about trusted code and running workflows with it?
Yeah, so this is one where, we're kind of talking about when you set up your workflow, you kind of have to understand what code is going to be running in your workflow. So if you have a workflow that's kicking off automated tests for the code that's being trying to merge in the pull request, those tests are technically actually executing that code. And so if you kind of have to be careful about what is executing, and then you also have to take into context where it's going to be executing. So one thing to think about is you might have self-hosted runners rather than GitHub's, ephemeral Ubuntu runners that are actually executing these workflows. And if you have somebody else's pull request code executing in your GitHub runner, then basically it's kind of opening that up for remote code execution. And so it's important to make sure that before you kick off these automated tests or these other workflows for a pull request, that you've actually taken a look at the code that's going to run and make sure that you understand, that this author didn't try to inject something malicious just to get it to run in your workflow.
Right, got it. I understand. All right, so we're starting to get near the end of this, but we have a couple more to go through. So harden your action runners. Okay, so what is an action runner?
Mm-hmm.
And we have here a reminder that we shouldn't use action runners in public repositories. So let's talk about that for a minute.
Yeah, so I kind of just alluded to that just a little bit ago, but basically a GitHub runner is basically the server or container that is running your GitHub workflow. So that's actually where these automations are actually happening. And so you can set up these self-hosted runners in GitHub so that all of your workflows run on a server that you control rather than an ephemeral GitHub runner. And so luckily, GitHub actually has protections and doesn't allow most accounts to use self-hosted runners on public repositories. And the reason that's dangerous is kind of what I was just talking about, where if somebody else opens up a pull request and is, executing their code on your GitHub runner, that is potentially, introducing malicious code into your environment on your server that you control. And so for that reason, if you do host self-hosted runners, because this is allowed in GitHub organizations, you need to make sure that you have protections in place and monitoring so that if something bad does happen, you take notice right away and can put a stop to it. If we want to think about a real world example, we can look back at the SolarWinds incident where, the build server of the Orion platform was compromised. And by compromising that build server, which is, kind of like a GitHub runner, where it's, they're kicking off those automated builds. Since they were able to compromise that server, they were able to inject malicious code into the Orion platform as it was being built. And so that's kind of an example of why you need to make sure that you protect your action runners.
Right. Okay. Okay. I got it. So let's move on to being careful with the pull request target trigger. So what's the pull request target trigger?
Yeah.
and why do we need to be careful?
Yeah. So this one's kind of subtle at first, but basically GitHub Actions in the workflow files, they have these different triggers that will kick off actions. So if it's a push to the repository, or it's a pull request, or maybe an issue opens, these are all different triggers that can kick off workflows. And a pull request target trigger is actually one of two different pull request triggers. So we have pull request, which is just one of those, and then pull request target. And the difference between those two is what context the workflow is running in. So when we have a pull request, we have two different repositories. We have the repository of the contributor. So let's say that Mackenzie owns a repository, and I'm trying to create a pull request to his repository. So we have my repository, which is the contributor, and we have his repository, which is the target. So pull request target runs in the context of the target repository. So where you're trying to push code to, that's the context that all these actions are running in. And that can get dangerous when you're running untrusted code inside of that pull request, because what's all included in that repository context is, say, our GitHub token. So like we talked about earlier, by default, the token has read and write access. And so it enables things like code injection into the repository just by creating a pull request. And if it's confusing now, I'll be giving a demo on that here in a little bit, and basically showing you exactly what's possible here.
Okay, awesome. I can't wait for the demo. All right, so we have an example of this, and you said you would do a demo. Could you just do a little run through about what we're seeing here, and why is this example a vulnerability?
Yeah, so basically here we have a scenario where we have a pull request workflow that's kicking off, and basically it's setting up some Python dependencies, and then it's running some command. And let's just pretend that some command is kicking off PyTest, or some sort of testing for the code that's being committed. So what's happening here, you look at the trigger up at the top where it says on pull request target. So like I said earlier, that's running in the context of the host repository. So the place where the code is trying to merge into, that's the context that we're running in for this check. So as we look down at the steps of the workflow, if you look at the checkout action, that first step there, so we're using actions checkout at v3 with ref. So basically what this is doing is it's grabbing the code from the contributor, and then it's checking that out and running that in the context of the pull request target repo. And so when we go down and we kick off our tests, then what that's doing is it's basically giving the contributor, it's giving them write access to the repository, and effectively bypassing the whole idea of a pull request.
Okay. Well,
yeah, and I'll be demonstrating that here in a little bit.
Yeah, I can't wait to see that demonstration.
It's a lot easier to see it rather than to try to explain it.
Yeah. Well, I think you did a great job, and I think it will help us follow along in that demonstration too. I'm not gonna pretend that I know everything what you just said, but as I said, we are going to be doing a live demo of some of these exploits. So we have one last one. Now, this is the last best practice that we're going to go through, and then we're going to get stuck into some of the demos of how these actually work in practice. So prefer OpenID connects to access access cloud resource. Can you talk through your preferred OpenID and what's going on with this one here?
Mm-hmm. So sometimes in your GitHub Actions workflows, you might need to do things like interact with a web service to, upload a scan report or something like that. Or maybe you are deploying code and you might have to use some sort of API token to be able to access the environment where you're going to be deploying the code. And so OpenID Connect is it's kind of a single sign-on provider. So it's kind of an alternative to SAML, but it's actually more geared for APIs, and it's kind of more lightweight than SAML. And so how you would use this in a GitHub action is it gives advantages over longer-lived tokens. So you might have, say in GitGuardian, you might be able to create an access token to GitGuardian and basically just put that in your repo as a secret. Well, with OpenID Connect, if that's available to you, what that actually allows you to do is to create single-use tokens rather than these longer-lived tokens. And these single-use tokens, if one of those gets compromised, it's no longer valid. So it's just a more secure way to access cloud resources. And GitHub has quite a bit of good documentation on that if you want to read further.
Okay, cool, definitely. Well, look, we've come to the end of this. So these here are kind of are 7. I've combined 2 of them in here because 8 didn't fit. So 7, but actually 8. Best practices. Now, we have our entire blog and a cheat sheet to help you follow along to this. But right now, I'm pretty excited because CJ, let's see some of this in action. Let's see what actually happens when we don't follow these best practices. Now, I've been reading through a couple of comments, and there's a few people saying that a lot of these should be, should be self-evident, but some of them can be very simple mistakes to make, and it is the problem is that it only takes one of these mistakes to be made. If we trust something a little bit too much to be able to kind of get exploited. So, CJ, I want to invite you here to share your screen. Well, I guess I can control that, and we can have a look at this in practice. So, the show is yours.
All right, you guys can see my screen and everything, right? So basically, we have a repository that I set up here, and it's a private repository because it's got vulnerable workflows, and I don't want random people submitting pull requests and trying to exploit it. But basically, in our scenario here, we have an open source repository that's got some main code. This is kind of the body. This main script. This is kind of the body of our code. And then we've got this script over here that is going to be running tests in our CI pipeline. So if we look at the workflows that are set up here, we have this vulnerable pull request automation. And so the first thing that I'm going to point out is that this automation, as part of the automation, is printing out the name of the pull request. So maybe the developer wanted to identify the exact pull request title just to make it easier to reference that when they're looking at the actions output. So what they're doing here is they're just echoing that variable that contains the pull request title. So the way to exploit this, if we go to this other branch that I have, and we'll just pretend that this is some external contributor. If we make a pull request from this branch here, we're going to change the name of our pull request, and we're going to call it this command here. And I have a web server that's kind of staged for this, and it's got a bash script set up that I'm going to be running in the CI pipeline. And I can just show you, oops. I had too much of it highlighted. Sorry about that. So basically, this bash script is just emulating, dropping malware and then executing that on our runner. So when I create this pull request, it'll start kicking off some automations here in a second. And if we go watch the vulnerable pull request, what's going to happen is when it echoes the name of the pull request title, it's actually going to inject that code that I put into the pull request title, and it's going to put that on the command line. So if we look at this step here, print pull request title, you can see that the code actually injected and it ended that echo command, and then it actually made that curl request and then executed the script. And so obviously that's not something that we want to happen in our environment. So what we would do then to prevent that is we would do what I talked about earlier, where we create an environment variable called PR title, and then we use that on the command line, which effectively de-weaponizes this untrusted input that we have here.
Right. So that script that you did before, I mean, that could have been anything malicious, and then by making it an environment variable, we're basically saying that that this isn't, like, not to execute these instructions. This is just a title.
Yep, exactly. And then the second type of injection, we'll come back and look at our vulnerable workflow here. This is the one that I was kind of alluding to earlier, and this one gets a little bit more scary. So we're running in the context of the host repo, but what we're doing is we're checking out the code of the pull request. And so I've got this other contributors repository here, and they modified the test script. So instead of just running tests, it's going to be stealing the API key, which is a secret in the GitHub repository, and it's just going to be shipping that off to that same web server in just a curl request. And then the next thing that it's going to do is the scary part. So what this is going to do is it's abusing that GitHub token that it has access to, and it's actually going to be modifying the main code of the repository and pushing that directly to the origin repository. And so basically what's going to happen is, as soon as I create that pull request and it kicks off these automated tests, it's actually going to be modifying the main branch of this repository without even merging the pull request. So let's go see what that looks like. So I'm going to open a pull request, and it doesn't really matter what I name it here. I'm just going to create the pull request. And here in a second, it'll kick off the automation. So if we go watch what happens when it actually kicks off those tests, we can look and see, okay, so we were stealing the API key. It made that curl request and shipped it off to my web server. And then down here, we're abusing the GitHub token. So it modified that main script that's kind of the body of our repository, and then it actually made a commit and it sent that to the main branch. So if we go back and we look at our repository and we check out that main script, well, let's back up for a second. We can see that the most recent commit was from this GitHub runner bot, and it's got this seemingly inconspicuous commit message. But if we look at that commit, we can see that a curl request, that same malicious curl request that we were making earlier, was actually injected into the body of our code. And again, if we look back at the pull request that we just opened, the code hasn't been committed yet, but it was able to modify the main branch because it had the permissions from that vulnerable workflow.
So
Yeah, go ahead.
I just want to stop you. Yeah. So this pull request has been made by a third party contributor. Now,
Yep.
we haven't accepted this pull request. Like, we haven't added this into our code yet, right?
Right. Yep. And we can even close the pull request and say we're the repository owner and we recognize that they modified that test script and we want to just close it because, we identified that it has malicious code in it. But we might have overlooked the fact that even after we close that pull request, it already modified our code. So this is the main branch of our repository, and that pull request had basically bypassed all sorts of access controls, and it already injected its code into the main body of the program.
So this is insane. So yeah, wow. So from a malicious actor using GitHub Actions, they can inject code even if we do not accept their pull request. That's wild. That's absolutely wild.
And so the way to protect yourself against that, if we look at the safe check, is rather than using pull request target, we use pull request. And this ensures that, the GitHub token that the pull request is using does not use or does not have write permissions to the main branch. And that kind of concludes the demo. If anybody has any questions, we can cover that as well.
I had a slide for that and everything. There you go. Q&A. Well, look, CJ, that was fantastic. So thanks. So, I know that's probably a lot for everyone to follow along. What I do want to kind of emphasize is that all of this is outlined in a very detailed blog post with a cheat sheet that comes along with it. So if you're kind of struggling and go, okay, you want to know the code, you want to know the examples, you could go through this again in your ledger and be able to see in more detail, more clearly what's actually going on. Because I know in a live area, it can be difficult. So all of this is on our blog. Well, it's a big banner. At blog.gitguardian.com. You'll find the cheat sheet in there, but at the end of this webinar, I also have I have a link and some a QR code. So if you want to live dangerously and scan a random QR code on the internet, you can do that, and I promise it'll take you to the right place, and not a malicious website. Okay, so look, I'm gonna go through and look at some of these questions that we have. And so even if you haven't asked a question, please go in the question area and upvote your favorite ones so that we can get to the right ones. Okay, so the first question here, is it secure to run external workflows? For example, being AWS ECR login.
I'm going to assume that you mean external actions inside of a workflow. So yeah, in general, if you trust the publisher of that action, which is probably AWS, if you trust the publisher, then that's okay. If you're not sure about the publisher, it might be a good idea to actually look into the code of the action. So in order to publish an action on the GitHub marketplace, you actually have to have a public repository that shows the code that's going to be running in the background when you use that action. So you can actually go to that repository and read the code for yourself and vet it out if you're not sure about the author.
Okay, great. All right, let's move on to another question there. How are these changes done by adversaries that are logged? So I think the question, I'm going to try and rephrase. How are these changes done by adversaries when they're logged by GitHub? Oh, that one's just disappeared. Okay, we'll try and I'll try and answer another one here. Okay, is the presentation deck going to be available? I can answer this one. This one's an easy one. Yes, the presentation deck will be available. We'll make that available along with the video. There we are. Is there a way to scan action scripts automatically?
By action scripts, I think, would that be like the GitHub Actions workflow YAML file?
Yeah. So the YAML. So when we're writing our code, is there a way to is there a tool? I guess like SAST. We have these tools for for finding misconfigurations. Is there something similar for GitHub Actions?
That's a good question. To my knowledge, I don't think there is. If you have a SAST tool that is configurable, you might be able to create your own detections for that. But yeah, to answer the question, to my knowledge, there aren't any tools out there that come pre-built with detections for this type of thing.
Right, got it. Right. We have a couple of questions along those lines too. Is Git Guardian capable of preventing this title pollution? So short answer is no. No, we can detect secrets in different areas, but we can't solve all the problems. And so what I always say when it comes to Git Guardian should be one tool in your toolbox when it comes to having secure coding. There is no silver bullet solution. And whilst we're all expanding our capabilities as fast as we can, it's always good to have multiple tools in here. Okay. Does it protect other branches outside of just the main branch? So I'm assuming that's another question of Git Guardian.
The
yes.
I'm guessing. So yeah. So basically, the workflow that runs will only have modification access to whatever it's running in the context of. So let's say that you have pull request target, and it's a pull request to a non-main branch. Let's say you have a development branch and it's a pull request to that. Then the context GitHub token would have access to that development branch that you're trying to merge into. But to answer the question, if you use just the pull request, it should protect all of the branches because it's only running in the context of the contributors repository. So whatever branch or whatever repository that they have, it's only running in the context of that. So anywhere that they open a pull request to would not have that right access.
Okay, cool. There's a great question here that's actually been upvoted quite a lot. So this is great. Does this vulnerability apply to private repos? So basically, what are the security risks of having private repos versus public repos when it comes to GitHub Actions? So can you talk a little bit along that?
So the demo that I just gave was actually in a private repo. The main thing to think about is going to be, have you granted permissions to the repo to anyone else? So if you're the only one that can see your private repository, you don't really have to worry about these things because technically, if you're the only person that can even create a pull request or interact with the repo in any way, you don't really have to worry about it that much. But if you've given somebody else access to your private repo or a group of people access to your private repo, then technically, yes, you do have to worry about, what they might be able to do, or if somebody takes over one of their accounts, what they might be able to do with that.
Okay, that makes total sense. And and there's the other thing too to remember about private repos is that we put so much trust in our private repos, and I'm always a big advocate of kind of acting like our repositories and implementing similar security practices as if they're public. So you've probably all heard of like lapsus breaches that have happened where they published Samsung, Nvidia, and Microsoft source code over the internet because they didn't pay ransoms. And a lot of people were wondering, how did this band of teenagers, as we later found out lapsus was, get access to all this sensitive source code? And basically, they were recruiting people on their Telegram channel. So have a look at have a think about in your organization, everyone that has access to your private source code. Okay, there's your developers, there's your interns. You might have hundreds of them, you might have thousands of them. And how many of those could potentially sell access to an adversary if they wanted to? So I hate that I don't like fear mongering on this because this isn't a scenario that is super likely, but it can happen. And if we act like our repositories are public, then this can also help. That's my 2 cents. Not that anyone asked, but I thought I'd give it to you anyway. All right, I think that's kind of it for some questions. I'm just having another look. Okay, yeah. Well, I will say, CJ, you can't see the comments that are coming in here, so I thought I'll read a couple of comments to you here. Awesome demo, CJ. Thanks. Absolutely fascinating. That was both fascinating and frightening. And we have a whole bunch of other ones. So, CJ, I would like to take this opportunity to thank you as well for this. And so the audience really loved it, as I knew they would, because nothing beats a live demo. And as I said at the start, we do have some prizes. So remember, if you don't win a prize today, you can still win some stuff by emailing me your stories about leaked credentials. They can be anonymous. I promise I won't share any other inside. But the reason why we're asking for these is because it happens to the best of everyone, to leaking credentials. So I'm going to quickly share a story that involves me. Very quickly, 30-second story. I was creating a video for YouTube about what happens when you leak credentials in a public GitHub repository. And I was using Canary credentials, but I got mixed up. And I published a real secret whilst making a video about why you shouldn't publish secrets. Now, luckily, it wasn't the end of the world. It wasn't access to GitGuardian's production service, but it was access to my personal AWS account. I revoked the secret immediately. I knew about it, so even when you're making a video about why you shouldn't leak credentials publicly, you can accidentally leak credentials publicly. So feel free to share those. All right, but we do have a couple of winners from that here. I'm going to go to my analytics, and I'm going to try and find out who were some of our most active attendees. We had 231 people attend this webinar live, and I'm sure we'll have a lot more afterwards. So thank you, everyone, for attending. It was absolutely fascinating. And I'm just scrolling down to see the most active attendees. So here we are. Now, if you've been to these before, you'll know that I have I have a terrible track record when it comes to pronouncing people's names. But we do have some with us. So Baden Erb, congratulations. I'll be in contact with you. I'll put your name in here so that in case I've mispronounced it. And also Andrew Kamani. Congratulations to you two. You guys have both won some prizes. And I'll be in contact as well. Our most active attendee has already won a swag bag, so I won't give you another one. Although I don't think you've received your first one. So last month. So, but anyway, look, I think that brings to the end of the webinar. You always know it's getting to the end when I start waffling. So thanks everyone for attending. This was fantastic. Thank you again, CJ. It was perfect. Now, if you scan this QR code, it will take you to the blog post that CJ wrote with content writer Thomas. It's a fascinating article that will help and show some of what we've talked about today. And I think that call to action button should be happening too. So there's also a link. There's also a link down there. If you don't want to scan a random QR code, then you can type that in manually too down the bottom, or you can go to our blog. We have lots of content there. So that's it. That brings us to the end of the session today. So thank you everyone again for participating, for being here. And thank you again, CJ. Now, we do this every month. So if you haven't already, make sure you follow us on Crowdcast so that you'll be alerted next webinar. And also check out our YouTube channel where we also have lots of other content on there as well. So yeah, thank you everyone. Thank you, CJ. And hopefully we will see you guys next time.
Thanks for having me.